So first, what I'd like you to do is, if you need to pause me, please do me a favor and read this question very carefully. Read it a couple of times, actually. All right, so basically this is a rate in, rate out problem. So what I mean by that, again, is first of all, they're talking about a rate, and unprocessed gravel is coming to a plant. So this is your rate in. And this represents the equation that goes with that rate in. Okay? All right, so understand then, again, that this is technically a rate of gravel coming into the plant. And then what happens is, so the gravel's in a truck, it comes in to the plant, and then between the hours of 0 and 8, by the way, okay? And then what happens is during the hours of operation, the plant processes that gravel. So this is the rate in, and this is the rate out. Okay, so they're processing gravel, so it becomes processing gravel at a rate of 100 tons per hour. So that is your rate out. Okay, now I did kind of purposely overlook one important fact, and it says at the beginning of the workday, time 0, the plant has 500 tons of gravel. That's an initial condition. We may not use that in part A, but we are going to use that. All right, so then let's look at what they're asking for in part A. So part A says find G prime of 5. Well, here's your G equation, and they want G prime of 5. Now I understand that for the 2020 AP exam, you're not going to have a question where you would actually have to put this in the calculator, but I want you to understand the concept of it. So my suggestion to you then would be just to, let me get back to my pen here a second. In your Y1, I would plug in your GT equation. Okay, and once you have that in there, you go to your home screen. And then remember, you're just going to do math 8, right? So that's your end deriv, okay, of what's in your Y1. And we're going to evaluate that at x equals 5. Go ahead and do that and see what you get. All right, so I have G prime of 5 is negative 24.5875. Okay, now let's look at the units here. Okay, because if we look at the G, here's G, G, this is in tons per hour, and what we did was we just took the derivative. So what are the units that need to go at the end of this? If G's original units are in tons per hour, what would be its derivatives units? Okay, so that would be tons per, oh my goodness, I don't know what's going on with my pen, sorry about that, hour squared. Okay? And then they want, in context of the problem, what that means. So the rate at which the gravel arrives at the plant, because G of T represents a rate of arrival, is decreasing. Now the reason why it's decreasing is because my answer is negative 24.5875 at a rate of blah, 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 tons per hour squared. And don't forget to write at time 5. Okay? So part B wants the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Well, we know the hours of operation are for time 0 to time 8, right? But unprocessed gravel, remember, this represents the rate of unprocessed gravel. So if we have a rate, which is what this is, but we want an amount, what do we have to do? We have to integrate, right? So we're just going to integrate from 0 to 8, the G of T equation, and then plug it in your calculator. So guys, what I want you to try to do is start to think about the words. So if For example, if they're giving you an equation that deals with rate, and then they're asking for an amount, just always think integration. Even if you're not sure what to do after that, you want to, on your AP, write something. Anything is better than nothing and could very likely get you points. So that's what we're going for here. As many points as we can possibly get. All right, so anyway, so throw that in your calculator, Math 9 that, and you're going to get 825.5510, and that is an amount, so tons. And there's your answer. All right, so part C says, is the amount, so think about what that means, is the amount of unprocessed gravel at the plant increasing or decreasing? All right, well, first of all, when I think of amount, I think integral, right? And they're talking about unprocessed gravel, right? So then I would say to myself, oh, well, wouldn't I then take the integral, because it says amount of unprocessed gravel, and this is rate of unprocessed gravel, so amount would be the integral, right? Correct. Then it says increasing or decreasing. What does that mean you do to what I just wrote right here? Increasing or decreasing, what should I do? Shouldn't I take the derivative? And then doesn't that just cancel out the integral? So that's really g, and in this case it says at time 5, so g of 5. Okay, all right, so we've got a calculator. You've got g in your y1. Figure out what that is at time 5, and put me on hold, figure it out. All right, so I have 98.1407. Okay, so that's the amount of unprocessed gravel coming into the plant, right? The rate at which it's coming in. Now, let's think about this, because they want to know if that's increasing or decreasing. Well, isn't the rate that it's getting processed 100 tons per hour? So this here represents the rate of unprocessed. Okay, so it's a rate coming in, and this is representing processed. I don't know if I just spelled that right. Processed. Okay, so let me try this again. This is the rate of processed in an hour, right? We are processing gravel at a rate of 100 tons per hour. And this is the rate of unprocessed. So this is the rate coming in. This is the rate going out. I'm going to say that again. This is the rate going in. This is the rate going out. So they're talking about the unprocessed gravel. That's the rate in. Is the rate in increasing or decreasing at this time? Do you see that 98 is less than this? So wouldn't that mean that it is decreasing? Okay. So this would be your explanation. So the amount of unprocessed gravel is decreasing because 98.1407 is less than 100. Now another option for you, if you wanted to do it this way, what you could do is you have in your y1 the g of t equation, right? So couldn't you look at the g of t equation, which by the way, when you put it in, it's going to look like this-ish, and find out where time 5 is. Oops, that's g of t, by the way. Here's time 5. Okay, follow that up, and do you see that the graph is decreasing at that time? And if you get this value right here at time 5, so you could do second calc and go to value and plug in 5, you'll get that 98.1407. Okay, so you could say it's decreasing because the graph of g of t is going down or decreasing at time 5. That's another option. All right, so this is another major reason why I did this question, even though for those of you that are taking 2020, you may not, AP exam, you may not necessarily see something like Part A or Part B in terms of how you do the computations in a calculator. All right, so anyway, so Part D says, what is the maximum amount? So right away, I think maximum, what does that mean? Okay, so maximum amount of unprocessed gravel at the plant during the hours of operation on this workday. So they want the maximum amount of unprocessed gravel during the hours of operation. So I'm going to start with just finding, like, I'm going to call it like an amount equation. So this is what I said way back in the beginning here. Don't forget, at time 0, we have 500 tons of gravel to begin with. So we're going to start with 500 tons of unprocessed gravel. Then we're adding to that. Now remember, rate in, rate out basically is an integral of the rate in. I'll write this down. Don't know what is going on with my pen here. Rate in minus the rate out. That's generally what we do when we do one of these problems. Okay, so amount, remember we're starting with 500 tons of unprocessed gravel plus, okay, and then we are going to integrate from 0, to T right now. Okay, rate in, well, that's G of X minus the rate coming out, which is 100. Okay, and what we're going to do is put that in parentheses and then write dx. Okay, so notice again, I'm going to go back to this and I will box it in red. They want a maximum. What does it mean that I should do to this equation if I want a maximum? Doesn't maximum usually mean derivative? So basically what I'm going to do is I'm going to take the derivative of the left and I'm going to take the derivative of the right. Okay? And when we find a maximum, we usually take the derivative and we set it equal to 0, right? Okay. So just for argument's sake right now, I'm just going to call this amount prime. We'll deal with that in a minute. Amount prime equals, well, if I take the derivative of 500, won't that be 0? So that disappears. And if I take the derivative of an integral, won't those cancel out? And then t just goes right in here, right? Okay, so then basically what I have is g of t minus 100. Okay, and then when I want to find a max or min, wouldn't I take that derivative and set it equal to 0? So basically what I'm looking for here is, where does g of t equal 100? Well, you have a calculator. So again, we did this in part C. Your g of t picture kind of looks like this. Oops, I don't know that actually it goes down like that. So let me undo that. Actually, I'll just go like this. Okay. And then, so this is my g of t. And then I want to see where it equals 100. So why not in your y2, just go right ahead and plug in 100. This is 100 right here. And just do second calc intersect and see at what time that is. So why don't you pause me and figure that out? All right, so you should have gotten t equals 4.9234. Now, let's just look at this. Don't you see that prior to this point, do you see that g of t is above 100? And then after that point, it is below 100. So positive, then negative. So we definitely have a maximum here. Okay, now let's go back and read the question, because the question says, what is the maximum amount of gravel? So it wants how much. during the hours of operation on this workday. So it wants to know how much gravel do we have basically at this time. So remember, when you have a value, or t-value I should say, and they want the actual amount, isn't that like finding a y-value? So then basically what I'm going to do is I'm going to take this 4.9234 and I'm going to plug it back in here. Okay, so this is what I mean. So I'm going to plug in for that time. Now we know it's reaching a maximum at time 4.9 blah blah blah. So now we want to figure out what the amount is. Okay, so then your amount at that time, so at 4.9234, is going to be 500 plus, and then you're going to put this in your calculator. So why don't you pause me, work that out, and see what you get. All right, so I have 135.3761, and then the total amount is going to be 635.3761, and that is going to be tons, right? Because it's an amount. Oh my goodness, I can't spell tons. Tons. There we go.